Hi everyone, my name is Suram and I welcome you all to my YouTube channel. In today's video we are going to discuss about the chapter Calorimetry of standard 10th, in which we are going to discuss about heat and energy and temperature, heat capacity and specific heat capacity. So let's start. So very first is the heat energy. Heat energy is what, as we have discussed from the lower classes, heat energy is the sum total of kinetic and potential energies of all the molecules in a given substance. So we know that when a certain quantity of heat energy is applied to a body, it increases the kinetic energy of its molecules. So this results in the increase of average kinetic energy of the molecules, and hence the temperature of the body rises. So conversely, if heat energy is given out of the hot body or the hot substance, it results in the decrease in the average kinetic energy of the molecules, and temperature of the body decreases, temperature of the body falls. So here, what is temperature now? Temperature, it is the average kinetic energy of the molecules of a substance, whether it is solid, liquid or gas. So when two bodies are at different temperatures are brought in contact with each other, the heat energy always flow from a body at higher temperature to a body at a lower temperature. So it means the temperature, it is the temperature which determines the direction of flow of heat energy, is it? So the branch of physics which deals with the measurement of heat energy, that is known as calorimetry. So in the laboratory, temperature is generally measured in Celsius. So now we talk about the units of temperature. In laboratory, temperature is generally measured with the degrees Celsius, and however its SI unit is Kelvin, denoted with the symbol K, without any degree. So temperature on the Kelvin scale is equal to temperature in degrees Celsius, because both the scales are having the 100 divisions. So it means 1 unit rise in temperature in Kelvin scale is equal to the 1 degree rise in temperature on the Celsius scale, and vice versa. So 1 Kelvin rise or fall is equal to 1 degree Celsius rise or fall. So what is the difference between heat and temperature? So there are some points. One is the definition of heat and temperature: a form of energy which flows from higher, hotter region to a cool region. Then temperature, the degree of hotness and coldness of the body. If we talk about the unit of heat, it is joule, and unit of temperature as a unit is Kelvin and degree Celsius. It flows from a hot area to the cold area, increases when heated and decreases when cooled temperature. And furthermore, heat energy is an additive quantity, while the temperature is not an additive quantity. So heat can be measured by using the principle of calorimetry, that is, heat absorbed or given are equal, and temperature is measured by using the thermometer. Now let's talk about the units of heat energy. Units of heat energy: earlier the heat energy was measured in calories. So calorie is what? 1 calorie is the quantity of heat required, quantity of heat energy required to raise the temperature of 1 gram of pure water to 1 degree Celsius. That 1 degree Celsius is 14.4 degrees Celsius to 15.4 degrees Celsius. That is called the 1 calorie, is it? However, if we talk about 1 kilocalorie 1 kilocalorie is equal to 1000 calorie, that you're knowing already. The quantity of heat energy required to raise the temperature of 1 kilogram of pure water through 1 degree Celsius, that is called 1 kilocalorie. So kilocalorie, sometimes it is called the big calorie, or doctor's calories also, denoted by the capital C, calories. Calorie with the small c, it is a simple calorie, and capital C calorie, that is called the kilocalorie. So we know that the heat energy is measured in joule, is it? So as the heat energy is the form of energy, so therefore it should also be measured in joule. So 1 calorie is equal to 4.186 joule, or approximately it is 4.2 joule, and 1 kilocalorie is 4186 joule, or 4200 joule approximately. Then next is the heat capacity. Heat capacity is what? The amount of heat energy required to raise the temperature of a given mass of substance through 1 degree Celsius or 1 Kelvin. That is called the heat capacity, of thermal capacity of the substance. So it is very important. The amount of heat energy required to raise the temperature of a given mass of substance through 1 degree Celsius is called the heat capacity, or it is also known as the thermal capacity. So heat capacity is denoted with capital C dash, that is equal to H over theta, where H is the heat energy supplied and theta is the rise in temperature. So you should know the formula as well as the definition. Heat capacity C dash is equal to H over theta. And now, what are the units of heat capacity or the thermal capacity? Since heat capacity is having the formula H over theta, so its unit of heat is joule and unit of temperature is Kelvin. So joule per Kelvin or joule per degree Celsius. Other units are calorie per degree Celsius. Unit of heat is calorie also, so it is calorie per degree Celsius, kilocalorie per degree Celsius. So these are some units of heat capacity or thermal capacity. So in case of thermal capacity or heat capacity, mass is unspecified, is it? So thus the same substance can have different heat capacities depending upon its mass, is it? For example, the heat capacity of 10 gram of water is 42 joule per degree Celsius, whereas the heat capacity of 100 gram of water is 420 joule per degree Celsius. So factors on which the absorption or heat absorption or heat given out by a body depends. Heat absorbed or lost by the body is directly proportional to the mass of the body, that is H is directly proportional to M, is it? Heat absorbed or lost by a body is directly proportional to the mass of the body, is it? Directly proportional to mass of the body means more is the mass, more is the heat absorbed or heat lost. Heat absorbed or lost by body is directly proportional to the rise in temperature, is it? That is H is directly proportional to theta R. Theta R means rise in temperature, or theta F. Theta F is fall in temperature. So directly proportional relation is there. It means if one quantity will increase, other will also increase. So rise in temperature is more, it means heat absorbed is more. Fall in temperature is more, it means loss in heat is more. So heat absorbed or lost by the body is directly is given by mc theta r or mc theta f, where m is the mass of the body and theta is the rise in temperature, theta f is the fall in temperature, and c is the constant of proportionality. That is called the specific heat capacity. So heat absorbed or lost is always represented by the formula mc theta, is it? mc theta, it can be theta r or theta f. So simply you remember the formula for heat absorbed and heat lost. And C here is known as the specific heat capacity. So let's discuss about What is specific heat capacity? Specific heat capacity is denoted with the small c. So the amount of heat energy required to raise the temperature of a unit mass of substance through 1 degree Celsius or 1 Kelvin, that is called specific heat capacity. Here, what is the difference between heat capacity and specific heat capacity? Heat capacity was for the given substance, and specific heat capacity it is about the unit mass of the substance. Is it? Here we are considering the mass of the substance. Is it? In heat capacity we are not talking about the mass, it is the given mass of the substance. Is it? So this is the slight difference between the heat capacity and specific heat capacity, so that you must remember, because it is asked what is the difference between heat capacity and specific heat capacity. So SI unit of specific heat capacity is joule per kilogram per Kelvin. Joule per kilogram per Kelvin. Or CGS is joule per gram per degree Celsius. Or calorie per gram per degree Celsius, kilocalorie per kilogram per degree Celsius. So what is the relation between specific heat capacity and heat capacity? So heat capacity, we are knowing the formula H over theta, and specific heat capacity is equal to H over m theta, because H is equal to mc theta and C will be equal to H over m theta, that we are knowing in the formula already. So H over theta here is H over theta is equal to C dash. So it means if we combine these two equations, so in these two equations here H over theta will become C dash over m. So it is C is equal to C dash over m. So it means thermal capacity is equal to mass into specific heat capacity. That is the relation you must remember. Heat capacity is C dash is equal to mass m into specific heat capacity C. So we have some heat capacity of some common, specific heat capacity of some common substances in the table. Like water is having 4.186 joule per gram per degree Celsius or 1 calorie per gram per degree Celsius. Aluminium 0.9, clay 1.4, copper 0.386, lead 0.128, olive oil 1.97, silver 0.23, steel 0.448. So if I say the specific heat capacity of water is 4.186 joule per gram per degree Celsius, then what do you mean by this statement? Sometimes it is asked into the exam also, that specific heat capacity of water is 4.186 joule per gram per degree Celsius. What do you mean by this statement? So simply you will write the 1 gram of water, whatever the substance is given, that substance you need to mention in the definition. The 1 gram of water required 4.186 joule of heat energy to raise its temperature by 1 degree Celsius. Is it? If I say the specific heat capacity of copper is 0.386 joule per gram per degree Celsius, what do you mean by this statement? So here the copper specific heat capacity is 0.386. Only you have to write in the definition by using whatever is given. Is it? We are given in the statement that specific heat capacity of copper is 0.386 joule per gram per degree Celsius. Is it? So it means 0.386 joule is the heat energy required by 1 gram of copper to raise its temperature by 1 degree Celsius. Is it? So this you need to remember how to write the definition. Then we have next the difference between heat capacity and specific heat capacity. So heat capacity, it is the amount of heat energy required to raise the temperature of the given mass of substance through 1 degree Celsius, and specific heat capacity, it is the amount of heat energy required to raise the temperature of unit mass of the substance through 1 degree Celsius or 1 Kelvin. So heat capacity is a variable quantity for a given substance and changes with the change in magnitude of the mass, and specific heat capacity, it is a constant quantity for a given substance and hence fundamental characteristics of that substance. Heat capacity SI unit is joule per Kelvin, and specific heat capacity, its unit is joule per kilogram per Kelvin. Heat capacity is given as mass of the substance into specific heat of the substance, and specific heat capacity is given as heat absorbed by the substance over mass into rise in temperature, or we can say C dash over M, that is heat capacity over M, mass. Then what is a calorimeter? Calorimeter, that is a thin cylindrical vessel made of thin sheet of copper, as you can see in the diagram. Inside the calorimeter is a thin cylindrical vessel that is made of thin sheet of copper, and its outer and inner surface are highly polished so as to prevent the heat lost due to radiation. So it is generally placed in the rectangular wooden jacket lined from inside the wool or cotton wool or glass wool or asbestos, that is the insulating materials are placed around it. So these materials are poor conductor of heat energy and hence it prevents the heat loss due to conduction also, is it? And at the top, the calorimeter is covered by the wooden lid, is it, having two holes, one is for the thermometer and one is for the stirrer. So the lid is coated with the tin or aluminum foil from inside. So this lid prevents the heat loss due to the convection and radiation, is it? So no heat is lost by any of the process in case of calorimeter, is it? So whenever the calorimeter is weighed, it is always weighed with the stirrer that is made of copper, is it? So this copper made calorimeter is used for the measurement of heat lost or heat given to the substance. So what is the principle of calorimetry? So this principle of calorimetry is based on the law of conservation of energy. Law of conservation of energy is what? The energy in a system can neither be created nor be destroyed, and the sum total of energy remains constant. So when a body is brought in contact with when a hot body is brought in contact with the cold body, so the heat energy flows from the hot body to the cold body until it continues till the hot body remains at the same temperature. So according to this principle, if no heat is lost to the surrounding, then, or if the system is fully isolated, then, or fully insulated, then heat energy given out by the hot body is equal to heat energy absorbed by the cold body, is it? So here we consider a substance P of mass M1, specific heat capacity C1, and its temperature is θ1, mixed with the cold substance Q of mass M2, specific heat capacity C2, and temperature is θ2, such that they attain the constant temperature θ. So fall in temperature of the hot substance is having initial temperature θ1. So when it mixed with the cold substance, its temperature is becoming θ. So it is θ1 minus θ, fall in temperature. And rise in temperature of the cold substance, initial temperature is θ2, so final temperature is θ, so it is θ minus θ2. heat absorbed by the cold substance. Heat absorbed is having the formula mc theta. So that is m2 c2 theta minus theta 2. That is the rise in temperature. And heat given out by the hot substance, that is again mc theta. That is m1 c1 theta 1 minus theta. So if no heat is lost to the surrounding, then heat given by the hot substance is equal to heat absorbed by the cold substance. So that is m1 c1 theta 1 minus theta is equal to m2 c2 theta minus theta 2. So this is the principle of calorimetry that will be used later on into the numericals. So this was all about this part. Next part we will discuss in the next videos. Thank you.